This is Dr. Anna Murupriya, Associate Professor Tripoli from Rohini College of Engineering and Technology, Palkulam. We are discussing about the transmission and distribution course for the regulation 2021, which is discussing about the sag and tension process of the power system. What is sag? Sag is normally the difference in the two levels or the 2 points of support and either whatever it be, either one of the point of support and the lowest point on the conductor. This is what is called sag. On pictorially representing, let us consider a wire AOB. The length, the height difference between the point A, because it is a support point, and O, which is the last end of the wire at a vertical level. So that distance is known as S, which is nothing but the sag. Due to the sag, there may be tension at both O as well as at B. This is the case. So now we have to calculate the sag and the tension. Normally, the sag can be adjusted such that the tension in the conductors is within the safe limits. Tension is governed by the conductor weight, effects of wind, ice loading and temperature variations. So let us see about its calculation. First one, when supports are at equal levels. You can see this diagram. Here the two supports are at equal levels. You can see the distance between A and B is L. So it is bisected as L by 2. And here you can have the sag at O. So the tension at O is T. The distance between O and B is L by 2, and let us have a small weight or the self weight of the conductor, which is directed towards the ground. It can be W into X. This is a point X where I am considering here, so it is W into X. Let this be the distance X by 2. Also let us consider a point P at the line or the sagging line. Let the distance be Y and let it have a distance of X. So this is what is the case. Next, while considering the T into Y value, considering T into Y value. Here we have the L as the length of the span, W is the weight per unit length of the conductor, and T is the tension. Now we have Ty is equal to Wx square by 2. So y is equal to Wx square by 2t. This is y value. Let us have the maximum dip represented by the value of y either at the supports A and B. So at support A, x is equal to L by 2 and y is equal to capital S. So S is equal to W into L by 2 the whole square divided by 2 into T. We get S is equal to WL square by 8T. This is the case for the supports that it is at equal levels. Suppose if it is a hilly area, then the supports will be at unequal levels. So in such a case, we can have point x1 and then x2, a different one. And here it is s1 and here the distance is s2. And here we have the difference between point A and B. The vertical difference is height. Let L be the span length, and then height is the difference levels between the two supports of x1, x2, etc. And then T is the tension of the conductor. Already we have calculated. So S1 is equal to Wx1 square by 2t. S2 is equal to Wx2 square divided by 2t. On having the we are in need of the distance. So S2 minus S. On substitution, we get the value for H. While substituting that, you can have x1 and then x2. Now, with respect to the effect of wind and ice loading, the normal formula of sag will not consider such effects, and here the action of wind and ice has to be considered. Due to ice loading, it will be vertically moving downward, the line, and due to wind, it will be horizontally moving on the sides. See, this is the ice loading which is pulling it down, and this is the wind which is going for horizontal motion. So this is the final phasor diagram. The W effect due to the wind, and here it is due to the self weight W plus Wi, ice loading. So upon taking the parallelogram law, we will have this Wt, which is nothing but the resultant value of the ice loading and the weight due to the wind action. So Wt is equal to square root of W plus Wi the whole square plus W the whole square. Obviously, we can have the calculations and substitute. Thank you.